Hello everyone and welcome back. My name is Mr. Kovault, and in this video I'm going to be going over equation stoichiometry and ideal gases. So let's get into this. So just a reminder of equation stoichiometry. That's when you are going to be using a balanced equation to help you convert from moles of one thing to moles of another thing using what is called the mole ratio. Where do you get this mole ratio? You're going to get it from the coefficients of the substances you are converting from and to. Okay, so we've seen this in other videos where you're going from mass of one substance to mass of a different substance. And remember, the overall general steps that you are going to be taking in any of these sorts of problems where you are asked to convert from one substance to a different substance is always going to be the following. One, whatever unit they give you, you got to convert that to moles, right? So maybe they give you maybe it's a mass to mass conversion, right? So they give you some unit of mass. You're going to have to get that unit of mass to moles of that substance. So you're going to take that unit, and the first step, if that unit is not already grams, you're going to have to convert that to grams. That's your first step, right? And then convert that grams to moles using the molar mass. And now you've got moles, right? That's the first step. That's the first goal, I should say. Maybe the first goal is a better way of putting it. So your first goal in the problem is to convert whatever unit they give you to moles of that substance. Second step or second goal after you've reached that goal is to convert the moles of that one substance to the moles of the substance that they want in the problem. Okay, so to do that, you're going to use the mole ratio between the two substances in your balanced equation. Okay, so that's goal number 2. So you go to that. So reach that goal. Your third and final goal is to take the moles of the substance and convert it to whatever unit they want. Now, if they want that second substance in moles, then you're done, right? There's no other step to make. But if they want the moles converted to some other unit, then you're going to have to convert to that unit. If it's grams, then you're going to use the molar mass of that second substance to convert to grams, and then you would convert grams to whatever the unit is. If it's already grams, then you're done. But if it's milligrams or kilograms or something like that, then you have to use a unit conversion to convert to that. So that's the 3 main steps. The substance that you're starting with, convert that to moles. Then once you get moles of that first substance, you convert that to moles of the other substance. That's goal number 2. And then the third and final goal is to convert those moles of that second substance to whatever unit they want. That is the overall strategy or plan or, strategy for lack of a better word, of that you're going to apply in these problems. Okay, so we've also seen this with the stoichiometry using solutions, right? We use molarity as a conversion factor, right? So remember, molarity is moles of the solute over liters of the solution, right? So we have a conversion factor. We can use that to convert to moles, right? So if they give you liters of solution or milliliters of solution, you follow the 3 main steps, right? Convert the unit of the volume unit of the solution to moles, convert moles of that one solution to moles of the second solution, and then you convert moles of that second solution to whatever unit they want. If it's liters or milliliters of another solution, then you got to use the molarity to do that, right? So again, we've gone through that in my other videos, so I'm just kind of recapping those to kind of give you a refresher. In this case, we're going to be using gas stoichiometry. So we're going to use the ideal gas law to help us convert to moles. So the steps are always the same. So here's the general steps regarding gases, right? So if you're given the volume of substance number 1 and it's in a gas and they give you some unit, let's say it's not in liters, right? So let's say they give you meters cubed, right? So they give you meters cubed of gas number 1, and they want you to convert that to a volume, maybe meters cubed of gas number 2, right? So maybe gas number 1 is a reactant and gas number 2 is a product in the problem, or vice versa. Maybe gas number 1 is a product and gas number 2 is a reactant. Or maybe gas number 1 is a reactant and gas number 2 is the other reactant. So many possibilities here. But the idea here is that if they're giving you gas number 1 and it's not in liters, then the first thing you want to do is use unit conversions to convert gas number 1 from that unit to liters, right? So if it's meters cubed, then I know that 1,000 liters is equal to 1 meter cubed. So I can use that to convert meters cubed to liters. Once I get to liters, now I can use the ideal gas law to help me convert liters to moles. And there's a couple of ways you can do this. The first way is to use R, the R constant, as a conversion factor. So let me remind you about the R constant. So there's two values for the R constant based on the units. So you could use R is equal to 0.082058 liters atmospheres over 1 K for Kelvin mole, right? So you can see that I have a numerator and denominator. So I can use this as a conversion factor. So I can plug this into my conversion factor process, and I can eliminate or I can cancel out units as I add more conversion factors. So you could also use this value here if you've got kilopascals as a pressure unit. So you'll notice here I have atmospheres as a pressure unit. Here I have kilopascals as a pressure unit. And so you can see that the numbers are different. Make sure you use the right R value for your particular problem with its particular given pressure, units. Okay, so you could use the R value as a conversion factor. And again, I have example problems where I go over using the R constant as a conversion factor. Or the other method is, instead of using R as a conversion factor, what you can do is once you get the volume of the gas in liters, you can take those liters and plug it into PV equals nRT, right? So this PV equals nRT, the ideal gas law equation. So all I did was I solved this for N, right? So I want to find the number of moles. So I'm going to take the liters, plug that into this equation for volume, my pressure unit, whatever that is, R, whichever value of R I'm using here, and the temperature, make sure temperature is in Kelvin. So volume should be in liters, pressure should be in either atmospheres or kilopascals, depending on which value you're using here. And then I just plug it in and I solve for the number of moles. So that's another option you could do. And then once I get the number of moles here, then now I have the moles of gas 1. Now I've reached the first goal in my overall method of solving this problem. So then once I get moles of gas number 1 from this part here, either using N equals PVO over RT or R as a conversion factor, now I'm going to use the mole ratio from my balanced equation. I'm going to take the coefficients of the two substances that I'm converting between, use that as a conversion factor to convert from moles of gas 1 to moles of gas 2. And then at this point, I'm done with the second overall step. Now the next thing is to convert to whatever unit they're asking for. In this case, I'm assuming that they're going to convert to a unit of another gas. So in this case, then I would have to convert the moles of gas 2 to volume of gas 2. And again, go back to the two possibilities. So I can either use R as a conversion factor again to help me convert my moles of gas to liters of the gas, or I can just take the moles, so I can again, I have moles, and I can solve for the volume of the gas. So let me fix this. So the proper form actually would be, so I would solve for volume here. So then volume in liters is going to be equal to nRT over P. So I could use this form of the ideal gas law equation and find the volume in liters, and then go from there. So either way works. And then once you get volume in liters, if they don't want in liters, if they want in some other unit like meters cubed, then you would have to use unit conversions to get to the unit that they want you to convert to. And so this is the general equation, but this assumes that you're going from gas, substance one, which is a gas, to substance two, which is a gas. But we've learned, as I said in the beginning, several different ways of converting between things using stoichiometry, right? So they don't have to give me a gas to begin with. They could give me a solution, right? Maybe I'm mixing two things together and I form a gas as a product, right? So they could give me the concentration of one of the reactant solutions, and then they could ask me to find out the volume of gas produced, right? So in this case, I would be starting with a volume of a solution, maybe in milliliters. So I would have to convert the milliliters to liters, and then use the molarity they give me to convert from the liters to moles, and then I go from there, right? And then I would go from use the mole ratio to convert from moles of my solution to moles of the gas produced, right? And then I could use the ideal gas law to convert from moles of the gas to liters, and then to whatever unit they're asking for. So that's a possibility, right? Or they could give me, maybe I'm throwing a solid into a solution and it's producing a gas, right? So in that case, I could start with a mass, right? They give me grams. I would have to convert grams to moles, or maybe they give me kilograms, right? So I would convert kilograms to grams first, and then I would have to use the molar mass to convert from grams to moles of of solid. And then from there, I use the mole ratio, and then I get gas, and I convert to the gas product, right? And then I follow the rest of the steps. So you can mix and match these all you want, right? Maybe I'm reacting a gas with some other solution and it forms a solid, right? So you have a lot of different ways in which you can use your equation stoichiometry to solve problems. So that's what we've been going over in a lot of the videos dealing with equation stoichiometry. Okay, there's one more thing I want to point out to you that's very helpful is STP. STP stands for, let me write it out. Oops. Standard temperature and pressure. Standard temperature and pressure. So what is standard temperature and pressure? Standard temperature is 0 degrees Celsius or 273.15 Kelvin. And standard pressure is 1 atmosphere or 101.325 kilopascals or 760 millimeters of mercury or 760 torr. So this is standard conditions. So you want to pay attention to whether or not the gas you are given is under standard conditions. If the gas you are given is under standard conditions, then what you can use what is called the molar volume. And what that is that under these conditions and only under these conditions, 1 mole of any gas, doesn't matter what the gas is, 1 mole of any gas is going to be equal to 22.414 liters. Okay, so if you know that under these conditions, 1 mole of a gas is equal to 22.414 liters, you can use this as a conversion factor to convert between liters and moles. So under standard conditions, at this point here, if gas number one is under standard conditions, then you can use this as a conversion factor to convert between liters and moles. Same thing here. So once you get to moles of gas number two, if gas number two is under standard conditions, then you can go ahead and use the molar volume. 1 mole is equal to 22.414 liters to convert from moles of gas 2 to liters of gas 2. Okay? But you have to pay attention to the conditions, because if those conditions don't hold, then you cannot use this, right? So this is only for standard conditions, standard temperature and pressure. So you can be given a problem where, say, gas number one is under standard conditions, and then you can use this molar volume as conversion factor, but then gas number two is not under standard conditions. So then you cannot use this as a conversion factor. You'll have to use one of these two strategies here. So pay attention to the conditions you're given. If you are given standard conditions, then you can use this, and this will cut down some of the work, right? So that's very important to keep in mind. And that's it for this video. I hope this video helped you in some way. If you enjoyed this video, then please like the video, share the video, hit that like button over there somewhere. Also, make sure that you subscribe to my channel, hit that notification bell. When you do, make sure that you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a particular problem you want me to cover, or a particular question, or if you have a topic that you want me to cover, please put that down below. I would love to do that for you. Thanks for joining me, and have a great day.